EET112 Lab1 again. Now I was going to show you a little bit about the section where you're going to program the square wave. So right now I still have the sine wave programmed for 50 kilohertz, 10 volts peak to peak. So I'm going to go to square wave now, and then I'm going to go to 7 volts peak to peak. And I'm going to go to 1 kilohertz frequency. So frequency 1 kilohertz. Okay, so what you see now is we've got our square wave and it's triggered center screen. Remember, right arrow and the trigger point. But we want to see more of the waveform, so I need to adjust the horizontal scale, which is now at 5 microseconds per division. Since we're running at a kilohertz, that's at a cycle of, it cycles every 1 millisecond. So I need to turn the horizontal to a larger time scale. So let's go to, there's 200 microseconds per division. And we see, about three cycles worth of the square wave. And then I can turn the vertical amp up 1 notch and fill the entire screen, and still not clipping. So it's always important to try to get the most, when you're looking at a signal, you want to make it as large as possible on the screen to get more accuracy in your measurements. Okay. So now what we're going to do is we're going to give it an offset voltage of 3.5 volts. So we're going to take this waveform and add a DC voltage of 3.5 volts to it. So it's going to push the whole thing up 3.5 volts. So I'm going to go to offset 3.5 volts DC, and it did push it up, but now we're not triggered anymore because remember the trigger is down here at the bottom now. So I need to move this trigger point up with this knob here. Okay, so now it's triggered, but now the problem is it's gone off screen. But I can use this position knob on the vertical channel 1 to turn it down. So let's get it all the way back on screen now. There we go. I can put it exactly in the center if I put minus 3.5 volts for the positioning. You notice that the arrow on the left here, which has a little number 1, that's always ground. So it's saying 0 volts now is down here at ground. And notice that since we've got 7 volts peak to peak, that must mean this is 7 volts up here. And if I want to reposition the trigger, I can push this knob again. It's not going to change anything because that edge is it's pretty much vertical. So whether I trigger up here or down here, it's not going to matter in terms of where it's putting that waveform. Okay, so now I think what we're asked to do is put it into AC coupling mode. So what AC coupling mode does is it takes out the DC component of the waveform. And so to do that, you go to the channel 1 menu. Oops, I turned it off. And over here on the left, you'll see DC coupling. Let's put that on AC. And now what you see is now the waveform's gone down here because now we're stripping out all of the DC component, but our 0 volt level is still here. So if I push this button, that should recenter it. Yeah, so now 0 volts is back on the center, and this is what we wanted to see. But you have to remember, since you're AC coupled, it's now stripping out that DC component. Okay, hopefully that makes sense to you. And let's see, is there anything else I wanted to say about that? Oh, No, now we wanted to check out the cursors, I think. So I'm going to go ahead and put it back on DC coupling. And then recenter and move the positioning down where I had it before. Minus 3.5-ish. Yeah. And then we're going to use cursors to measure the bottom and the top of the waveform to get the peak to peak. So turn on the cursor menu. We're on Y1 right now. So that means when I move this knob, this is Y1. We'll put that up at the top. So I'm measuring the top of that square wave. And now I'll change it to Y2, push the knob, and now just Y2 to go to the bottom of the waveform. Kind of center it there. That's pretty close. So you can see Y1, which is at the top, is at 6.96. Y2 is at about 20 millivolts, pretty close to ground. And delta Y tells you the difference between the two, minus 6.96. So that's about what the scope thinks the peak to peak is. Now notice the measured peak to peak is 7.12. So the cursors, depending on how good your eyeball is to put them where you want them, it's probably not as accurate as the scope. Now we can also use the cursors to measure the period by changing from Y mode to X mode. And now notice the cursors are vertical. So let's adjust X2 since that's selected. We'll put that, for example, right here, as close as we can to the vertical. And then I'll change this to X1. Select it and put this one over here so that I capture one period. So vertical here goes down, back up. So that's one period of the waveform. And we look over here and delta X, 1.004 milliseconds. So pretty close. Remember, 1 kilohertz. To get the period, you take 1 divided by the frequency, which is 1 millisecond. And our cursor measurement is pretty close to that, delta X of 1.004 milliseconds. So that's how you use the cursors. I think that's all I wanted to say about that. Again, let me know if you have any questions.